Good morning or good afternoon, everyone, depending on where you're joining us from, and welcome to today's webinar. My name is Eugenia, and I'll be your host. It's our pleasure to have Stride with us today, who will be presenting this webinar titled Survey Modeling of an Onshore Vibroseis Nodal Seismic Survey in a Desert Environment. Let me introduce our esteemed guest speakers for today. Mehdi Tasher, Sales Director at Stride, and Claudio
Hello.
Cardama, Senior Geophysicist at Total Energies. Now I'll provide some housekeeping information before we start. First of all, I would like to welcome you to our webinar platform On24. You will notice that this webinar is browser-based, so if you disconnect for any reason, please just click on the link that you received via email to rejoin the session. During today's event, there will be plenty of time to ask questions to our speakers. You can do that via the questions widget. Just type your question in this box and click submit. Also, we encourage you to send in the questions throughout the webinar, anytime throughout the webinar, and our presenters will address these questions live during this event. So don't forget to explore our resource library, where you can find downloadable materials. We would also like to invite you to fill out a short survey, which you can find in the survey widget. If you require any assistance, please use the yellow help widget, and you can move, resize, and maximize any of the windows in front of you to get a better view of the slides. But now, please allow me to welcome our presenters. Over to you.
Thank you, Eugenia. Welcome, guys. Welcome, everyone. Thank you, Claudio, for co-presenting this work with me. And we are ready, so let's start. We have an hour and we have quite a few slides, so we will start immediately. So the title of this webinar will allow us, hopefully, to go from design to cost analysis and to understand where should we, well in advance, plan our studies to ensure we get the most of our survey at a reasonable cost. So we have two case studies today. Both could be located in the MENA region, Middle East, North Africa, and also elsewhere if the kind of surface condition would be similar to what we are facing in the MENA region. The first case study will cover about 3,000 square Vibroseis. The second case study is a larger project, multi-year, as we can find them regularly in large countries in the Middle East. Those case studies are not the only one where we could apply the same logic than what you will see in this webinar. The logic is the same, whatever the size of the project and whatever the surface condition, the approach is the same. So bear with us, and as Eugenia said, feel free to drop your question online, and we will be pleased to answer those at the end of each case study. Webinar objective is based on design, trace density, density of receiver, density of source point, in our case is VP source point. We will look at how we can compare a cable crew, cable on geophone string, with what we call a generic X node and the Stride node. So that will be the approach, comparing in every scenario, sometimes with similar design, sometimes with different design, what are the cost and cost impact on the crew size, the crew resources, and the crew duration, and finally the crew cost for the customer. So a quick question, you will have a set of questions throughout this webinar. It's totally anonymous. Feel free to answer them. We have about 15 seconds before we'll see the answer online consolidated. So nothing special. Go ahead. It will help us understand where we start from and where we are going through those webinar slide and the exchange we do with you guys through the questioning. So you have about 10 seconds left. I guess that's enough. Let me disclose the result. So we have an audience today who, for about 70%, has already been exposed to Node. For about 20% has been switching fully to Node only over the last 5 years. And we still have more than a quarter of the audience who are cable-only user. So it's very interesting. I wouldn't dare to guess which region is what, because we have an audience from every part of the world today. But definitely, it's something that reflects the overall audience, and maybe not truly what happened with each region of the world where Seismic is ongoing. So allow us to present a quick video, a synthetic video. This video is very important because it has been made by Stride, comparing a cable with a video is the basis of what we will then drill into cost-wise, resource-wise, production-wise, going Node and eventually going Stride is the best possible scenario overall for your trace density, your quality output, and your project outcome in terms of duration, HSE, and cost. All right, so a few comments on the video. It's a synthetic video, digitally created, but it's fully representing what Stride has achieved on the market after 4 years of commercialization now, with multiple customers worldwide. We have about 250 projects today on all continents. And that is why today this product is becoming a reference on the market. One Stride node weighs about 125 grams. And in comparison, for all of you guys knowledgeable of Seismic, one string of 9 geophone plus a cable channel is about 12.5 kilo. So when you have 100 nodes in your backpack, Stride node, you have about the weight of one channel of a cable plus a string. And this is one of the key elements totally changing the way we look at logistics and resources on the seismic route today. The other one is we bury fully the node below the ground whenever possible, which make your surface totally free of activities. Your own activity, seismic activity, vibrator, drilling, driving, third parties activity, congested oil field, farming, whatever, and vandalism on wildlife. So that's very important to keep that in mind while we go through the following slide. Claudio, all yours.
The Stride model that's down in the lower right of the picture here can show the relative size. Of course, you cannot sense it, but the weight as well, and how easy to transport at least this type of equipment is, especially in difficult areas like congested fields, sand dunes, etc., you name it. So the large advantage of this system is portability, and believe me, it has to do a lot with the well-being of the people in the field carrying those lighter type of equipment.
Key factor constraining your design and your budget. So we all know those are multiple. We would need multiple slides to list them all, but we made a selection of the key factor from project design, 3D, 2D sparse, receiver or source, surface obstacle, geological objective, depth, equipment, duration related to acquisition methodology, traditional flip-flop, DS4, DS3, blending ISS, very common now in the MENA region, daylight or 24-hour recording, availability of channel count, the limitation of layout on pickup capacity, which is a huge subject in the Middle East. We sometimes have more Vibroseis productivity capacities and layout on pickup capacity, especially with cable system, and downtime when you face a cable system. And finally, resources, human resources or supplies and consumable. This brings us to the next question that you can answer about the main factor driving cost and duration of an onshore seismic route. Do you believe, as a customer, as a seismic operator, as a seismic guy, that you have a clear understanding of what are those main factors driving cost and duration? 10 seconds left. Then we disclose the outcome. All right. So very glad to see that we have an experienced audience. That's even better for what we want to achieve today. 90+% of the audience today has a clear understanding of what are the main factors driving cost and duration. That's excellent, because then it will allow us to go even deeper in what we want to achieve today. Thank you. We had forgotten with Claudio one table of key factor, which is the environmental, the surface condition, what is on the ground. And that may be the one that has the biggest impact on what you want to do, on what you want to achieve. For the MENA region, flat gravel plain, desert, rolling sand dune, high dune, sabkha, farming, congested oil field in many areas of the MENA region. Seismic goes on in congested oil field, congested area. Could be facing demining in Egypt, in Iraq, Libya. Could be facing bulldozing line clearance in many places. Significant effort of bulldozing line clearance, which has a huge impact on your project cost. And this is where, for demining and bulldozing line clearance, you need to understand where do you want to put your effort, on the receiver and or on the source. The remoteness on the project, and finally, the social environment, people, third-party, wildlife. So overall, out of those key factors, we believe that the environmental aspect is really the surface condition, one of the driving element of the decision-making process. First case study, as I said, MENA region onshore, plus minus 3,000 square, Vibroseis program. Basic description, option for the cable, 301, option for generic X node, a node that is on the market, available. And the third one, stride node. So options 301, 201, 101 are all the same. 12.5 meter receiver interval, 200 meter receiver line interval. So the only differences between those three first scenarios are the type of equipment we are implementing. In this case, a cable with a string single phone. In this case, a generic node with a string single phone. And in this case, one stride node. That's the only difference. And in the last option, option number 4, we are putting double density of stride node by putting a receiver line every 100 meter instead of 200 meter. And everything else stays the same, but we are putting a little bit sparser the source line. So in the last option, we are comparing a design that is ISO for cable, generic node, and stride node with a stride density higher in receiver and slightly lower on source. Which give us, Claudio, please.
Yes, this is actually now with new actors in place. We can think about which part of the recording system we're going to weigh more, depending on the possibilities and the ground conditions. So sometimes we might be better to go for high source density, but other times we might as well go for receiver line, receiver's density, increase the receiving density and lowering the effort on the source side, just to adapt to the training conditions in a specific place. So this is not a recipe for every place, but depending on the conditions, we can go one way or the other, making the system more efficient.
Thank you, Claudio. And as a consequence, we have a trace density per square kilometer for options cable, generic node, and stride at about 23 million traces per square kilometer. And if we duplicate receiver density with stride node while slightly decreasing source density, we still have a trace density going up by about 30% to 31 million traces per square kilometer. So keep that in mind. This is a little histogram here, which is being on each following slide, reminding this setup of trace density for each scenario. Claudio?
Well, this shows basically the time needed to lay out and pick up the equipment. Evidently, the time that receivers stay on the ground, that is still basically related to the life of the battery, and that could be obtained from the different equipments. And allowing us to do it faster will actually ensure that we don't need to change the node of a very specific receiver location. We just pick it up and carry it out and roll it up again in front of the spread. And we know that cable systems take longer to do that. Well, then let's say the nodes independent of the size will more or less be the same. And doubling the nodes, we can even go faster with that in terms of productivity.
Yeah. So it's important to keep in mind that if the contractor or the company, customer would like to go 12 hours, whose time would almost double. So that's why it's important to find a node that does have a large autonomy to face every scenario. So layout composition, this is one of the key elements that will totally change the way we look at seismic with node in the MENA region. A conventional cable crew will require at least 12 persons per team. A generic crew with node will require about 5 persons, and a stride crew will require about 3 to 4 persons, including driver portion for support logistic. So when we look at the size of a crew, we have to take into account the number of teams. If we were to have, for this particular program, the requirement to lay out about 600 stations per day with cable, we need about 156 people in the recording team for layout. And if we are looking at layout about being a generic node, we need 60 packs, 60 people for the generic node, and we need half of that, 30 people for the stride node. So look at the number, look at the size of the crew when you go from cable to generic node to stride node. It's extremely significant, and that's only for the layout team. And if you go double the density, you are still way below the cable size for layout. That will be shown in the coming slide. The same for pickup, exactly the same logic. You have a huge decrease in the quantity of personnel when you go from cable string to node string, and when you go to stride node only, even with double density. Very important to indicate that whenever you go stride node, you remove totally the heavy vehicle that you consider when you do a cable and string seismic program. The stride node team is anywhere between 2 to 3% per layout or pickup team. That's headcount optimization, summary, layout on the top, pickup at the bottom. You go from 160 to 30, 160 to 60 with conventional generic node. The drop is phenomenal. And it's even more important going with stride node, and you can notice here, when you duplicate the density of stride node, and you increase the trace density to 31 million compared to the conventional scenario, you still have a lot less employees than with the cable system. And you are about at the same employee count than the generic node. That's fully optimized. Some department also will benefit from less people in recording, like the basic crew, the base camp. When you go stride node, we do not survey anymore the receiver line in advance. Receivers are surveyed as they are layout, because we have an integrated system, semi-automated, that allows for surveying while we lay out. So those departments also will reduce the headcount. Claudio?
Yes, you will also have in mind, from the human point of view, the effort of carrying one or the other type of equipment. That will probably keep people happier to work with a small nodal system. We get rid of all the workshop that has to do with cable repair, and of course the costs of cables and connectors that are quite important, especially when channel counts are really high. So it's an optimization in many aspects. But in terms of the simplicity and the easiness of people working with this type of equipment is quite outstanding.
Summary of the headcount for the project. If you were going to run this seismic program with a cable string, single geophone string, you would need about 740 persons full-time on the crew running 24 hours. All departments included. If you shift to a generic node with a single string, you would need about 404. And if you go stride for the same design, same density source of receiver, you go 100 packs, 100 employees below the generic node. So you have divided at least by 2 the number of employees between the cable crew and the node stride crew. And this one, you duplicate the density of receiver, you still have 31 million traces per square, way better than your past design. You have decreased a little bit your source effort, and you only need 440 employees. This is really a key picture, key number to keep in mind, that you have divided by more than 2 the number of employees you require, with the corresponding effect on multiple factors that we will look at now. Project vehicle count. So you have a split there on the representation. Per type of equipment, vibrator obviously stays the same in every scenario, no change. Dozer, as we go faster with node compared to cable in terms of number of days for the acquisition, you need more dozer per day, but over the total project duration, the number of dozer days will decrease. Light vehicle goes down very significantly from 105 for a cable crew to 66 for stride node, same density. Heavy vehicle, as we said, no more heavy vehicle for stride node on generic node. And overall, you can see the total vehicle count for each type of equipment. Cable 176, down to 111 for stride node, and if you duplicate the node, stride node, you are still way below the cable requirement, and you are about the same than the generic node requirement in terms of vehicle. And reminding all of us that vehicle transportation continue to be the main cause of accident on LTI on fatality. Project CSR, corporate social responsibility, Claudio.
Well, as we all know, this is becoming one of the main subjects that all companies, especially the majors, are actually pushing for optimization in this respect. And the fact that we are using less vehicles, of course, when we're considering the vibrators because they are the same. But if that allows us to go faster, the overall consumption is going to be lower. And of course, having less heavy trucks would also contribute to reducing this impact. And it's pretty obvious from this graph what we can achieve using this type of equipment.
Claudio?
Then the fact that we need to move less equipment and less heavy loads actually reduces the amount of CO2 emissions during the project, and it goes in line with the general policies of the Paris Agreement, trying to reduce the amount of greenhouse effect gases that we liberate into the atmosphere, actually contributing to the general performance of our companies in this respect.
Yeah, and please have a look at the CO2 emission of the Stride double node density at 12 million kilo of CO2, almost half of the cable. I want to insist on that because not only have we designed an option with double density and a little bit less density of source point, which is providing the customer with 31 million traces per square, but the fact that we are not focusing on higher possible source effort means that we are saving fuel consumption, we are saving kilometer driven, and we are reducing by 2 the CO2 emission. And finally, man-hour on water consumption. On this program, about 1 year program recording, the Seismic company would save 850 water trucks if this project was remote in the desert, which is very significant for all of us who have been on Seismic crew, and would decrease their HSE exposure by about 66% compared to a cable crew. Those numbers are just phenomenal. One more question for you guys. Do you believe seismic project duration is an important element of your design and budget decision-making process? Please take the next 10 seconds to answer that before we disclose the outcome. Thank you. All right, here we go. So, 100%. Well, I guess this question was very important to make sure we all agree about that. Thank you very much. No contest. You can derive from this slide that the head count being one of the main costs of your seismic onshore, multiplied by your recording duration, is what will drive the total cost of your project. Keep in mind that those first 3 scenarios gray, light gray and red are for the same design, same trace density. And the last one is with higher trace density. So basically, we are dropping down to 191 days when we increase receiver effort and decrease slightly source effort. And finally, a picture that I believe summarizes the case study number 1, whereby for the 3 first scenario, once again, same trace density, same source density, same receiver density, cable, generic node or stride, cable has been considered as a base 100. So if the cable costs 100%, the generic node would cost about 62%, and the stride node would cost about 46%. If you take the whole program, including production mob, demob, 49%. So basically, a stride node program will cost half of your cable program for the same design, same trace density output. And the generic node will be about 13 to 15% above a stride node system. But if we go one step further and we double the density of stride node compared to the above scenario, while decreasing slightly the source effort, you can see we have 1.7 million VP for the first 3 scenarios. We go down to 1.1 million VP for the last scenario. Then the customer would pay 45% of what they are paying for a cable crew. This is thanks to the density. Yes?
It's important to point here that we are expecting that the contractor owns or leases both things in same conditions.
Yes, it's a scenario where the seismic company owns the equipment. It's a capitalization of expenditure. That's correct. Yes. Yes. And I forgot to indicate that those values are excluding taxes or profit on a 24-hour basis. This slide on CapEx, thank you, Claudio, for reminding us about that. The seismic contractor would purchase this equipment and utilize them for multiple years, at least 5 years, as usual in seismic onshore. And to purchase this amount of channel, about 100,000 channel for the 3 first scenario, cable, generic node, and stride node, same density. A cable scenario would cost 100%. Generic node plus a string of 1 phone will cost about 94%. The stride node system will cost 32%, which is 1/3 of those costs. So that's where really the difference is made for the seismic company in terms of purchasing their recording gear today. And if you were to consider more than duplicating the number of channels on the crew, you would only expense 76% of what you would expense for a cable system, with less than half of the channel count. And that's what is the market price for a purchase of a recording system for this kind of project.
Yeah, one of the advantages of the Nodal system is that can be scalable up to almost infinity, while a cable system can go up to a certain amount of channels. Even the most modern ones have a limit, a cap on that. So for the geophysical company, it's preferably to go for something that can be expanded with time and doesn't have a limit in terms of operationally.
Yeah, that's very clear that today a cable system beyond 120, 150,000 channel is becoming a headache for most of the seismic contractors. Finally, total project cost for Seismic company, excluding margin or taxes, but that would be more or less the same ratio for the end customer, the oil company, where you can see that for half of what you would pay for a cable crew, you would get your node crew with the same design and same trace density. And you would get an increased trace density, 31 million instead of 23 million, going to a double density of stride node instead of keeping a single density of node or receiver. A question to keep the audience with us. If you face a nodal solution cheaper per square kilometer, providing you with a higher trace density per square kilometer, would you go for it? Or would you stick with a cable string system to have real-time QC, despite the lower trace density? About 10 seconds for you guys to populate your answer before we disclose the outcome, please. Thank you. So about 94% of you guys would go for a cheaper square kilometer rate, providing you with a higher trace density. And I can tell you that this is certainly the way to go, and we have seen it in multiple regions, in multiple countries, where customers are now taking advantage of this nodal solution. Finally, a summary table that's more for the case studies that we will share after with you guys. We summarize the design, the trace density, and the cost evolution and the CSR value. So I will not extend on that, but you will have it afterward. Conclusion, semi-automated layout pickup and data management, buried node. Buried node is very important because you can easily imagine, if you look at these pictures, that this node can be easily buried, and this node cannot be easily buried. And that's why when you bury a node and you have the surface totally free for your activity, not to talk about the perfect coupling, geophysical coupling of a node buried below the surface whenever possible, then that's the best possible solution you get geophysically and logistically. Trace density per square is critical. What do you want to focus on? I would suggest you focus on your less expensive effort. Is it vibrator source point or is it receiver point? Most likely, in many scenarios, it would be the receiver effort that would be the less expensive and the less difficult to implement. And finally, minimizing resources, manpower, protecting the planet. As a consequence, saving money on being ahead of timeline. So that is the conclusion for case study number 1. We can take 5 to 7 minutes of Q&A. We are running a little bit late. If anyone wants to pop up the question, we can answer that with Claudio for now. Don't be shy.
Yeah, thank you very much. And yeah, just a reminder to the audience to ask questions. You can send them via the questions widget. Just type them in this box and click submit. And we've received several questions already. And here is our first one. Okay. 10-kilometer depth. What methodology do you advise in order to illuminate until debasement?
Claudio, you want to take this one?
I'm sorry, can I have the question again, please?
Yes, sure. 10-kilometer depth. What methodology do you advise in order to illuminate until debasement?
1 kilometer depth. Is that the
10
question?
kilometer depth.
Oh yeah,
10.
yeah, that's a question. Yeah, question number 9 in our box.
Yes, actually, that depends basically on the offset plane we're going to use, the sampling, what are the targets we need to illuminate. It's a matter of also signal to noise ratio. There's no fixed recipe for that. Needs to be considered. But in fact, if we can do away with nodal system that has the same geometrical characteristics of a cable system, it's going to be easily deployed and retrieved. So it's a matter of geometrical parameters more than actually the type of equipment.
Thank you, Claudio. We have another question. What about failure percentage harvesting data? So after 4 years of using our product, about 900,000 stride node on the market today, the failure rate is about 0.2%. So a reliability of about 99.8%. And the node is maintenance free. So when you have a stride node, you have zero maintenance. The node is totally sealed and has no maintenance to be carried on. Popping up is about GPS connectivity while burying the node. We have run tests with multiple customers in the MENA region. GPS signal can be achieved even at a depth of 75 centimeters below the sand. So that's something that is amazing. We have tried through testing. Obviously, we don't intend to bury the node 75 centimeters below the soil, but it could happen. Normally, burying the node 5 to 10 centimeters is a current practice. Another question, cannot be charged through solar? No, nodes are charged wireless at the camp. So it's not charged through solar. We'll have to park some of the other questions because we are running a little bit behind schedule. But we will keep all questions and answer them as an additional couple of slides with the presentation when the presentation will be made available online for all of you. And another question was, can we conduct any kind of source acquisition with a nodal system? The answer is yes. We are agnostic to any type of source, being explosive, accelerated wet drop, Vibroseis, whatever, even passive survey, being not active survey, and it could be for any industry. So let's now jump to case study number 2. We are still in the MENA region, but this time we are going toward higher density and on multi-year program, as we can face them in many countries in the MENA region where crew can be contracted for 3 to 5 years. So we are now seeing a clip of stride compact equipment. right. So this video was showing you a Stride automated container called Pro Container and/or Compact Container. When you get a Stride system, you not only get the node, but you get the full accessories, hardware and software to allow you to manage the node between pickup and layout whenever charging or downloading is required, and the node data management post-recording. So a question, and you have all the brochure available on our website and also on the webinar site regarding the Stride container capacity. How many nodes per day, 24 hours, can we manage in a Stride container, being Pro or compact? It's not similar but close. Is that 2,000 nodes per day, 10,000, 20,000? You have 10 seconds to answer, and I can tell you that it is very automated, and the number is quite important. And we have the only system on the market that is automated. We do not have today another system, node system on the market automated. Any other system today require each node to be manipulated one by one, whereas our node goes by batch of 90s inside the tray, inside the rack you've seen on the screen. Let's disclose the outcome. So we have a divided set of response, which is nice. So it's not 2,000. A compact system, a compact container would do anywhere between 12 to 15,000. On a Pro system, can take and digest 20,000 nodes every 24 hours. So that's very important to keep in mind, because this case study does show that in some scenario with extensive use of Stride node, we are moving up to 50,000 nodes per day, which is a number that may sound a little bit high, but it is totally achievable today with the technology we are providing. So what are we looking at now? As I said, the MENA region, we have two comparisons here. We have a 25-meter grid for receiver and 25-meter grid for source. In one case, we have a generic node connected with a 9 geophone string. And in the Stride scenario, comparing with this generic node on 9 geophone string, we have 4 nodes also in a square array. So both a geophone string or the node 4 node are laid out in a square array. And compared to that, we are coming with a degraded design where we decrease receiver density. We put a receiver line every 50 instead of 25, and but we still have either the generic node plus a 9 geophone string or a Stride node times 4 per receiver station. So before the raw data gives a volume of trace density that is really very impressive, either 369 million or 1.4 billion traces per square in the first case comparison, and then a lower density in the second case comparison. What is important is how we propose to manage this data set in the coming slides, and what is the effect on the project cost. So an important point, today managing so much data volume is very difficult from a processing perspective. Processing shop today, the cost of hardware and on the service to manage so much data, if not through digital group forming first, is cost prohibitive. So the solution Stride propose is to digital group form in the field, and therefore going from this trace density on the equivalent data volume to DGF group forming of the stride node, native raw data, so that we have the same data volume that what the client want to achieve with a geophone string on a generic node. So to avoid an overrun of cost for processing for the customer, we are providing inside the Stride Compact or Pro container a flawless in the field digital group forming that will allow the customer to process the same data density than what he wants to achieve with a generic node on a string of 9 phones. And obviously, the cherry on the pie is that this native data set is available with the customer whenever in the coming days or year, maybe multiple year, processing shop will add capacity and performance to process larger volume at achievable cost. DGF would be could be multiple as a cross factor, as a square factor, and therefore those node space as per the design would sum up into one channel. This is how the DGF work in practice. A question for the audience. In the case of a very high density multi-year survey, do you believe that automated node handling and data management post-recording is a key element of a cost-efficient node project? Yes or no? I will disclose that in the next 5 seconds. Here we go. So that's a unanimous answer, and we totally agree indeed. If a customer wants to go toward a very high density multi-year or a very high density, not multi-year, but 1 year or less, definitely our recommendation is to have an automated node handling system for the node pickup, rotation to layout, data downloading, node battery charging, and keeping in mind that the critical step is the data management. Recording data is difficult, but is not the critical step of the high resolution survey. The most critical step is data management. And the solution we provide is all-in-one from hardware to software inside our container, flawless as an output from the in-field QC. The same one, Claudio, if you don't mind commenting. We cannot hear you, Claudio. So while Claudio reconnect his mic, allow me to tell you that if we were to run this crew 30% 12 hour and 70% 24, the channel would stay, the node will stay for a generic node about 24 days in the field between pickup and layout, and for a stride node about 16 days because remember you have a string of 9 geophones laid out in a square box on the surface with a node on the surface, generic node. So, and you have a grid of vibrator shaking every 25 meters in line and cross line. And that's something that is going very disturbing. This node on geophone area on the surface sitting on the surface will be extremely disturbing for the vibrator operation. That's why it will take more time. Once again, the project headcount optimization, going from layout to recording department to pickup, there is an impact that is significant. I will summarize this. So those departments are ISO. They are the ones that do not change. And you have here the vehicle count. So heavy vehicle, you go down very significantly with a stride system. So you compare those two options with those two options, and those two options with those two options. So we go a little bit higher with a light vehicle, because we do not use any more heavy vehicle for recording in the case of stride node. And you go almost with no heavy vehicle for recording. The heavy vehicle, in the case of the stride node scenario, only for the vibrator department. CSR element, KPI, kilometer driven. Once again, the highest risk of your program in terms of HSE are significantly reduced because you go faster. So the program duration is a lot less. CO2 emission is drastically reduced compared for the node scenario compared to cable. Fuel consumption, no-brainer. This one is really impressive regarding the project in terms of fuel consumption. And finally, once again, water consumption, total man hour. If you are inside the seismic crew, that's 4,000 water truck less in about 5-year time that you will be saving in terms of cost on HSE risk. Driving that in and out of the crew every day, and 40% less man hour when you go from a node plus string system to a buried node stride system. Combination of the crew headcount, complete crew, full time. We go from about 1,300 employees for a cable geophone. Sorry, generic node geophone. There is no cable in this case, study number 2. To 1,000 persons for a stride node. So at about 30% reduction in the crew count. And the recording duration is significantly reduced because you don't have any surface obstacle to deal with while doing a carpet shooting with your vibrator. Another question for you guys. Do you believe that the capacity of pickup, the capacity of the crew of pickup and layout in the field for a generic node on a string of 9 phone or for a stride node is a source production limitation factor for a cable crew? Do you believe that whenever you are in a cable scenario or a generic node plus string scenario, the limitation factor is the daily capacity of pickup and layout? Let's disclose the result. Yeah, so we have a very experienced audience, because indeed it is one of the critical elements to decide how to size your source department in case of vibrator, because you could certainly perform a lot better with vibrator, but unfortunately, whenever you face a string of geophone being connected to a node or to a cable system, you are limited with the the amount of the receiver you can move every day. As a summary, looking at financial, comparing the generic node plus a string of phone with a node system for the very high density, you would spend about 63% of what you would spend if you had the same crew with generic node on the geophone, if you go stride node. And with a lower density, you would spend about 69% compared to spending 100% with on a string of geophone. This is mainly due to the impact on the program duration. This is where you have the largest saving, plus obviously the reduction in the quantity of employee required on the program. See, you are about 350 days less when you go to a buried node stride compared to a surface node with a string of geophone. In the case of carpet shooting, 25-25. And the capex, very interesting to see that if you were to capex 241,000 generic node plus a string of 9 phone, and compared to capexing 4 times more, 830,000 stride node, you would only expense 81%, so saving about 20% of what you would expense for the generic node plus a string of 9 phones. So from a seismic contractor perspective, you would be saving money capexing a node system, stride node system, compared to a generic node plus a 9 phone array. Total project cost, as mentioned in the past table, if you go from the generic node 9 geophone to a stride 4 node array, where you have a huge increase in trace density, you would only expend 63% of your generic node and 9 geophone program. And a little bit more if you de-densify further both scenarios. The same summary table, we've seen all of those numbers. They will be left for you to work on them if you want. Conclusion, once again, buried node and coupling is unrevolved, especially if you are considering carpet shooting. In this case, 25 by 25 on the surface. Whatever the environment, open area, congested area, even more critical than open area. Recommendation, focus on your less expensive and less high-risk activity, certainly the receiver one compared to source activity. And today, yes, trace density can become costly and cumbersome for data management post-recording processing, but DGF in the field, as we can provide it in a compact or pro container, provide you a solution to keep the cost, the processing cost achievable, affordable, while having a data set that is unrivaled in terms of trace density that can be processed in the near future, where cost of processing larger data volume will come down. Final thought, for any project size, I want to insist on that. We have been showing example of the MENA region. Some of you may face smaller projects, shorter project in terms of duration. It doesn't matter. The logic we have exposed here today in terms of impact on resources on cost applies for large project, multi-year project, smaller project and shorter project. It is about how the game has changed because of the size of the node, because of the weight of the node, because it can be fully buried below the surface and let you work freely with any kind of activity, and let you stop worrying about permitting and what are the consequences of third parties or weather consequences on your surface geophone, surface node, or surface cable. Lower OPEX, reduce HSE exposure, faster and leaner field operation, increased trace density, that's a no-brainer, and obviously better processing outcome and better imaging for your interpretation. So we can go to the Q&A for the second case study. We are running a little bit late. We really appreciate the fact that you are staying online. I do have a lot more time, but we will have a few more minutes of Q&A before we conclude this webinar. Feel free to push any questions.
Yeah, thank you very much. And we have a couple more questions today. So here is our first one. Not real-time QC, but what about the final seismic image? Does the sensor used at STRIDE can compensate the 9 geophone elements? Okay, this is the question number 10.
Thank you. That's a very important. Yeah, that's a very important one. Thanks for asking. So let me refer to a very large project conducted in Oman by one of our customers for CCED, the oil company in Oman. It was conducted over the last 3.5 years with 175,000 STRIDE node. So no geophone string, single node, mid density in terms of receiver density, Vibroseis acquisition, Oman environment, desert, and after 3 years and a half of seismic, they have acquired about 12,500 square kilometers, a huge volume, a huge achievement, and on the company down under geophysical, a processing shop has been contracted to process all the data, and they are slowly but surely producing a very nice technical paper showing the data uplift they have obtained from this seismic campaign. So I invite you to look online at ACG, EAG technical paper. Doug and CCED have started publishing, and the data is so good that they went all the way up to a FWI process. So yes, we have multiple examples in multiple regions, and this one is the largest set of data showing that the data quality is there, even if it's not a string of geophone.
Yeah, thank you very much. And we have time for one more question today. And here's our question. I guess it's a kind of blind data acquisition. What are the QC steps to make sure that quality data has been acquired?
Yes, you are right. The STRIDE node is fully blind, do not communicate. So we have made multiple, obviously, tests at the beginning, more than 4 years ago, comparing our system to multiple systems, cable, node, in all environment possible. And we are still doing that from time to time, whenever required by customer in a new country, for instance. We also have reliability that is about 99.8% over the last 4 years, 900,000 nodes. You get to collect node every day from the field. You retrieve data every day. You download the data and you see the data immediately, so you have this quality control. And you can adjust in pseudo real time whenever the data come in. You don't have to wait for 1 month or 2 months before looking at your raw data in the field.
Thank you very much. And just a reminder that you can still send any questions while watching on demand. All questions will be answered at a later date. I would like to thank our speakers for what was a great presentation and Stride for sponsoring this session. To the attendees, you will receive an email telling you how you can access the on-demand version of this webinar. Alternatively, you can access it through our website, which is pmi-live.com. We look forward to sharing further webinars with you, so please do keep an eye on the website just mentioned. Thank you once again, and I hope you all have a nice day.
Yeah, thank